any of the speakers would like to either turn on the cameras or be available, both Frank and I will certainly host this if people wish. And there's Andy, so and Mark. Great, well, looks like everybody's hanging around. This is exciting. I'm going to start off with one question, then if Frank's around, I'll let Frank ask if he's got any pending questions. But as I indicated earlier in this session, we're talking about super high speeds, low power consumption. We've talked about the network. We've talked about a lot of materials. What are the common themes here? As I look forward, and certainly I'm very interested in road mapping where all this is going. I see integration. I see high speed, low power are the three key metrics over the next decade. Let me throw this out to all the folks on the panel here for a quick sort of elevator speech answer and see, is this right or is this wrong? I mean, are we heading in the right direction over the next decade? Andy, why don't we start with you?
Yeah, so power consumption is a very high order bit for essentially all hyperscaler customers. And one of the mishaps, quite frankly, in the 400 gig optics development was there's sort of three generations of implementation of 400 gig. The first one was with 16 nanometer gearbox, which was higher power and it's never going to get to volume. The current generation is in 7 nanometer, which is better, but still high power. And what people really wanted was the 5 nanometer gearbox today, which isn't here yet and will take another year at least. So one lesson from this is that the ultimate customer requirement, which was to be as power efficient as possible, was largely misunderstood by the market and led to a lot of, call it, duplicate investment and excessive, qualification cycles of 3 generations of gearboxes, which nobody wanted, and it just doesn't provide a good return for the industry that made those investments either. And the next time around, we got to go for the lowest power solution up front because everything else is just not very interesting.
Oh, great. Thank you, Andy. Great answer. Mark, have any thoughts on the question I posed?
Yeah. Well, as you see what IR Labs is doing, we're trying to kind of jump straight to the end solution of if you don't have to think about backwards compatibility and you're really just trying to build the densest, highest energy efficient solution, how would you build that with silicon photonics capabilities? So I agree with this trend of we're trying to escape as much bandwidth as possible from the edge of a chip. And the way to get there is through higher and higher degrees of integration. And so I agree with that trend. And the one caveat I would add is, the majority of the discussions in this panel are talking about the kind of Ethernet-driven roadmaps, which of course are very important. The bet that we're making is a bit more of a greenfield opportunity to try to go have optical I/O kind of penetrate the actual compute packages and compute to memory. So we think that optical I/O is going to look different for those applications, compared to the Ethernet networking solutions.
Oh, great. No, it's definitely a different direction. I'm going to jump to Superior. Could you give a really interesting perspective from Source? I mean, how does that question I posed affect your perspective?
Yeah, so definitely, like the way we are seeing in the market is the power is one of the question first come up in any discussion, and how can you reduce the power? So definitely that's one of the key driver what we are seeing, along with the cost, because these two go kind of hand to hand. So that's how we see it panning out.
Great. And let's see, Guillaume, you had a very different perspective. You're talking about, use of 5G. I mean, I was wondering where 6G would come, but, as you look forward, I mean, these sort of metrics, I mean, how do you see things playing out?
You mean from a 5G perspective or from a power consumption perspective?
Well, I think power is going to be very important. Let's just focus on that one.
Yep, yeah, absolutely. So yes, it's something we see, particularly when we do the testing of the live equipment linked to the train receivers. In fact, so this is a test we do to make sure that the management is not a problem when turning up a system. So that's part of the key elements to be tested when I was talking about the live equipment testing. So that's one of those, yes.
And Sanjay, you're looking at using fiber optic comm technology, applying it to really new and novel applications in the biospace. It's pretty exciting. Using materials, so low power, high speed. I mean, how do these sort of things play into where you're going?
It's the same optimization parameters, right? Whether it's optical comms or the transceiver or a pluggable line system, or we're talking about devices that consume very little power. A good example is our micro pump for an amplifier. It's an uncooled pump. It's a tiny pump, and it fits in these very tiny spaces. So power. So that's on the device side, but we also see, I mean, we spoke about diamond and thermoelectric coolers, and we see materials that are sort of naturally the best materials that are available for some of to drive the heat away from these surfaces. So we see a lot of activity there too, and it's as the other panelists said, it's probably the top 3, if not the top 2, in terms of power consumption.
Great. Let me, I co-chaired with Frank. Frank, do you have any sort of questions you want to throw at the panel?
Yeah, maybe I can ask the whole panel. I think it's Andy talk about, Super talk about, also Mark talk about also the integration. So a quick question is, what do you think about when the 800G will happen? Will happen sometime, or what is the roadmap look like currently? From switch side, from module side, from integration. So Andy, do you want to comment first?
So you're asking 800 gig optics transceivers, right?
Yeah, transceivers, the switches, they pretty much the whole ecosystem, right?
Yeah, so it depends a bit on the hyperscaler cloud vendor, but we hear that Google is very excited about 800 gig form factor optics, that they want to ramp in the market in the second half of next year. So I would expect that to catch significant attention, and the fundamental driving force is lower cost, right? The hyperscalers are already spending more money on the optics transceivers than the switches and the routers. So they're spending billions and billions each year on these optics, and reducing the cost of the optics, which of course goes hand in hand with volume, is paramount. And 800 gig transceiver has this potential of reducing by, say, 30 to 40% compared to the 400 gig generation, which is very significant.
Okay, Super, do you want to comment something?
Yeah, sure. So first of all, like we see the key driver along with the cost, as Andy mentioned, is also the power per 100 gigabit. If you recall the chart I presented, I mean, definitely we see a significant reduction in the power per 100 gig ports, if you assume in that math. So 800 gig looks much better compared to 400 or 100 gig. So along with the cost, power is the second key driver, and also the density, of course. So combination of the 3, we see significant interest. And on the module technology side, we see that technology is already there. We can leverage the 400 gig platform and just kind of double the optics to it. So that's how we see that 800 gig is coming sometime kind of middle of next year as a pluggable module.
So Mark, how do you think about from the integration standpoint from the PIC?
Well, I think it kind of goes back to, we're not really focused on intercepting the standards-driven optical transceiver market. So we're following more of what's happening in the compute world. So PCIe Gen 5, the CXL consortium, these kinds of things. But I think roughly the timing is kind of similar to what Andy said. I think we'll have, we're going to see kind of first prototype systems that use high-speed optical I/O to ship every single bit in the platform. We're going to see those be turned on by end of next year, and then kind of 22 and 23 are planned to be more of a kind of widespread adoption set of activities. So that's how we're viewing it. And again, we're kind of following more of what's happening in the compute and the scale out system architecture world, and it's not necessarily following Ethernet roadmaps.
Okay, thank you, thank you. Sergey, do you have anything to comment? I know 2.6 doing a lot of stuff. Module is one of them. So.
Yeah, I mean, it's nothing more to add. I mean, it's the same three problems, right? The cost and thermal, power dissipation, power consumption, and shrinking of the form factors. So.
Okay, thank you, Sergey. So I think we used to have a lot of 5G questions. So maybe I think it's we need to answer here. So will 5G will be around for a long time, or maybe we are going to see guidance 6G soon? So can you comment? I know Expo is have the 5G topic, right?
Correct. Sorry, I missed the beginning of your question. Sorry.
So basically the 5G timelines. So will 5G will be around for a long time, or we are going to figure out how to go to the 6G quickly?
Yeah, well, some charts I had there in the presentation, you see it's ramping up. So yes, we had some deployments that started now 2 years ago, but the adoption from end customer perspective is starting to ramp up this year and even more next year. We said next year is going to be 5 times more than this year. So it'll take a little time, for the adoption of the end customers to be there. So we can expect 5G to be around for a while. And also all the deployments linked to that are not finalized. So we know it'll evolve, but that's the current one that's happening now. And for the next few years, that's the one that will be the dominant one for sure.
Okay. So, Mike, so there's some questions from the floor. So, but something similar.
Yeah.
So yeah. So any thoughts about technology after 800G? But I think we talked about also.
I think we talked about that, and
Yeah.
I think at this time frame, there's some other award announcements. So I think we're going to have to close the panel session anyway.
Okay.
But I want to thank all the speakers. It's been a great session. I really appreciate the effort that was put in. I know Carl just turned up here. Sorry, Carl. We're in the throes of just closing down the session. Did you want to say anything, Frank, before we do that?
I think that's all. Thanks for everybody. So appreciate all the great talk. So there's other sessions. Please join. Thank you.
Yeah, thank you very much. Appreciate it.